Hey guys, and welcome back to another video on the channel. In today's video we're going to be explaining why an object with mass cannot travel at the speed of light, okay? So if an object has mass, it has momentum. Now if an object is traveling very fast, the momentum it has is its relativistic momentum, okay? So special relativity, it applies to all moving objects, but it's only really noticeable when you're at multiples of the speed of light, okay? So if your velocity is like, let's say 20 meters per second, relativity is going to take an effect. But for example, if you wanted to work out your time, your proper time and your relativistic time, you're going to get exactly the same value because this Lorentz factor on the bottom is going to be so small it's not funny, okay? This is because the speed of light is an extremely large number, and since you're squaring it down here, what you're going to have is pretty much, for context, the speed of light is 3 times 10 to the 8 meters per second. So when this factor here, you're going to have 40 over this number squared, which is a ridiculous number. Now, if you have a huge number on the bottom of a fraction, this overall number is very little. So 1 minus a very little number, and you square root that, is going to be approximately equal to 1 when the velocity is very small. So that means your time is equal to your proper time, okay? The same thing is with momentum, okay? So momentum is mass times velocity, but if you're moving at velocities close to the speed of light, you have to use the relativistic momentum formula, okay? So momentum is mass times velocity, so this is Newton, and Einstein's formula, so relativistic momentum is mass times velocity over the Lorentz factor, okay? Now, with this thing here, let's just assume that pretty much the velocity is equal to the speed of light, okay? So we're going to assume the object velocity is equal. So in other words, velocity is equal to c. So what we can do is just substitute it into here, okay? So your momentum should be your mass. So the MO just means your initial mass pretty much, but it's just a subscript. It still just means your mass times by c. But what we get on the bottom is we get something a bit peculiar. We get 1 minus v is now equal to c because of this thing here. So the object is traveling at the speed of light. So we get c squared divided by c squared. Now c squared divided by c squared, or any number or anything divided by itself, is equal to 1. So what we have down here is 1 minus 1. Now that's 0. So what we have is MO times C over 0, which is technically undefined. But another way you could think about it, this is the same as infinity. So if we were to actually graph this thing here, okay, graph this equation, if we kept the mass constant, and the only things that were changing, so your variables are your velocity, so v is your independent variable. I think I spelled variable right, I'm not sure. And P, your momentum, is your dependent. That's not how you spell momentum. I think I was thinking of moment, so dependent. Okay. If you were to graph this and you were to keep this constant, what you actually get is something like this. You get velocity, you get P, and you get something like this. And now we have an asymptote when v equals the speed of light, okay? So even though it's undefined here, it's because we have a asymptote here, okay? It's undefined. But as you can see, as the velocity goes towards the speed of light, so this is the speed of light here, it shoots off to infinity. So what that means is, in order to reach this, you're going to need almost an infinite amount of momentum, okay? So for an object with mass to travel at the speed of light, it would require it would need an infinite amount of momentum. Now, if you have an infinite amount of momentum, you would need an infinite amount of energy. So if your momentum is infinite, then your energy is also infinite. And we know we can't have an infinite amount of energy, because then there would be no universe or nothing, okay? So that is why an object with mass cannot travel at the speed of light. Now, there is one thing that could potentially travel faster than the speed of light. I'll give you a hint. You see it every day, but you can only see it when you have light around, okay? So leave something in the comments if you can recognize what this particular thing is, and I'll leave you guys up for interpretation on the argument of that. If you do guess what it is, I'll let you know in the comments, but I'll see you in the next video.